Lesson 2 of Unit 7 is slope fields. We kind of led into this a little bit yesterday. Okay? Slope fields being just those little pieces of slope, right? So if we look at here, part of what we're going to be doing is we're going to be sketching slope fields. Okay, so that's a big part of what we learned to do in this lesson. Slope, vector, or direction fields are graphical representations of differential equations. You can use slope fields to visualize the parallel curves that solve the family of solutions to a first-order differential equation without algebra. For example, the equation dy dx equals y has the property that the slope at any point is equal to the y coordinate at that point. And it says, see the graph of the right. We can draw many line segments at each marked point showing the slope of the curve. And then the slope field will show the general shape of all the solutions. In order to sketch a particular solution, an initial condition is needed. So if we look at this one right here, and I'm going to give myself a little bit more room to work down below for the next example. But if we look at this equation right here, okay, that equation, that differential equation, is the differential equation for this slope field. And what they talked about, so dy dx, we know dy dx has the slope, right? Okay, dy dx is one way to say derivative. Derivative is slope. Okay, did I make the connection better? Now, notice it says, in this case, the slope is equal to y. So, for instance, so when dy dx equals y, I think I used the ordered pair. If we use the ordered pair, say 0, 1. What's that tell me? The slope is going to be what? Well, if the slope is equal to y, what's my y value here? 1. And the slope is going to be equal to 1. Well, if you look at the ordered pair, 0, 1, and it's slightly below, but does that little cross-section thingy look like a slope of 1? Okay. So, or the idea, I guess, at 0, 1, the slope would be 1. Okay. That's the idea. You'll notice that whole horn of blah, 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 blah. That whole horizontal row of y values has the same slope. Yes? Yeah. So they all have that same angled slope. If you get down here, for instance, down below the x-axis, slope are 1. Or slopes are negative, I mean. Gosh. So like you'll notice all these slopes have negative values. The closer you get to, say, -2 or +2, well, 2 is going to have a steeper slope than 1, right? So that's the idea of how a slope field works. And you saw yesterday how we can kind of draw a graph in to fit a slope field. Okay, and that's what they're talking about. To sketch a particular solution, you have to have an initial condition. So we have to know that, okay, we want to go through the point -1, -1 or something to be able to draw a particular solution. Okay, so we're being asked to sketch the slope field for dy dx equals 3x minus 2. And they give us a table and, ask us to use this table to fill things in. Now, you'll notice in this table, there's only an x value. They don't have a y column. Why is there only an x column? Because it's just 3x minus 2, right? There's no y value. So what that means is my slope is only going to depend on the x value. And remember again, dy dx is your slope. So, what x values do we have on our graph that we're going to have to know? Shall we start with -2? When x is -2, what's dy dx going to be? -8. Now, let's see. Let's go ahead and fill in the chart, and then we'll go do some drawings. When x is -1, What's dy dx going to be? -5. When x is 0, -2. When x is 1, and when x is 2, 4. Okay. In this particular problem, we only need x values. Okay. So let's work to graph these. Okay. When x is -2, the slope is -8. Now, what do you know about slope of -8? It's going to be very steep, and it's going to be very steep in a negative direction, yes? Okay, and that's whenever x is -2. So what I'm going to do here is at each of the, whoops, that one didn't stay very steep. I almost feel like mine aren't steep enough, but you're going to make them very steep. Okay. What about -1? Okay, that's, you have to reference what else is going on. Steep, but still very steep, but not as steep. So, and still in the negative direction. So can you attempt to make them, I say attempt because this is not an easy task. It seems like it should be easy, but I am forever second guessing. Is that steep enough? Is that, Okay, what about when x is 0? -2, so we're getting closer to having a -1, right? And -1 would be like the line that goes at 45 degrees. So we're getting closer to that. Ish, I don't know. Mine are getting less steep as I move, right? Okay. Now, what about when x is 1? Now we're going to have a positive slope, and it's going to be +1. So that is supposed to be, the 45-degree angle line. Obviously, this is not a perfection game. This is just, I'm going to judge, okay, in relation to the others, how's it working? And when x is 2, what do we know? It's 4, so we're going back steeper, but in a positive direction. I always think, oh, slope fields, this is easy, but it's hard trying to get them all like the same. Yeah. Okay. Now, this is your slope field. I'll be honest, I'm not sure I'm crazy about mine, but, I like mine in my notes better, but of course in my notes I was doing it on paper, so it was a teeny bit easier. Any thoughts on what a curve would look like here? Could it maybe be a parabola of some sort? Okay, and exactly. Okay, we don't know for sure until we do an integration, but keep in mind, if this is 3x minus 2, and you integrate 3x minus 2, it's going to become an x squared, isn't it? Okay. So this is indeed, it represents a family of curves that are parabolas. Does it say later? Because I have a random one drawn in. And I say a random one because did they give me a particular solution? No. But I don't know. Okay. Well, it doesn't go exactly with my line at 1, does it? But that could also be somewhat of my error. But that's the idea of what, one particular solution would look like. Obviously, there are lots of options moved up and down. Okay? So I am going to comment that slope field represents family of curves. And in this case, our family of curves are parabolas. If we take our equation, and sometimes this is easier than said than done, but if you take your differential equation and separate the x's and y's, you understand what I'm saying? So if I leave dy on the left, and I multiply my dx over, so it's 3x minus 2 dx. What can I do to that side to find, or do to this equation, to find the possible original equation? You can integrate, yes? We talked about this recently. When you integrate dy, it becomes y. If you integrate 3x, add to the power and divide by the new power, so I'd say 3/2 x squared minus 2x, and don't forget a plus c. Okay, not that it said to do that there, but there's your proof that it truly is a parabola. Okay, it truly is a parabola there. I'm not crazy about my drawings, as I said, but you have the idea. Okay, questions there? I will say some slope fields are easier than others. And sometimes it'll be about looking for patterns and whatnot. Let's try example 2. If we're good to go in example 1. Okay. Sketch the slope field, then use integration to solve for the general solution of the differential equation 2x minus y d dx equals 0. Now, at this point, there's a chart. Notice this time we don't just have x's, do we? We have x's and y's, which you would expect because we have x's and y's in the equation. Now, if you do some counting, we're not going to be able to necessarily list every ordered pair, but we're going to at least list some so we can kind of get an idea of, sometimes every point's going to be different. Sometimes we'll be able to find patterns, if that makes sense. Okay? Now, one thing I would recommend before we get started. 2x minus y dy dx. To plug in x and y to that form right there to find dy dx is going to be a little rough. I'd recommend, can we solve this for dy dx? Okay, that way you're plugging in x and y and you will know what dy dx is. So if I solve this for dy dx, okay, are you guys with him? So if we keep 2x there, he says add y dy dx over, and then divide by y. So that means that dy dx is going to be 2x divided by y. Okay? However you did that along the way. Personally, that's my recommendation of the equation we plug into. That's going to be a little bit easier now, isn't it? Okay. So I think the first time I went through this, I just kind of picked the left side of my graph and started. So like, for instance, if we start with that top left corner, -2, -2, or -2, +2. I'll get it. So into that equation we just solved, plug in -2, +2. Slope of -2. Let's go through. Can we do all the -2s and then we'll maybe graph them? We do -2, 1. What do we get when we plug in -2, 1? -4. -2, 0. What'd you say? Doesn't exist. I guess I have D and E written on there, which so that is doesn't exist, or in other words, no slope, if you will. Now, with that in mind, here's something we can learn from that. That's going to always be true what? When you have that 0 in the denominator, yes? So do we really need to do any work on anything else where y is 0? No. You know, be smart there. That's always going to be does not exist. Okay, what about -2, -1? Okay, +4. Sorry, my brain was working a little slow there. -2, -2? +2. Okay. Let's go ahead and put these slopes in. Well, or do we want to wait to the end? I'm trying to figure out, because I don't have them all listed. I know. Okay. Those are -2s. Let's do our -1s. Let's do -1s, and I'll kind of double up some of my boxes or run low. It is what it is. -1, 2. What about -1, 2? -1, 1. -2. Do I need to do -1, 0? No. Don't waste your time. -1, -1. And -1, -2. Now, what would be another smart thing to consider?
That 0 is a forward.
Okay. When y is 0, we have it does not exist, right? What about when x is 0? When x is 0, no matter what, it's always going to be 0, yes? When x is 0, it's always going to be 0. So that's another one that's always going to be true. And I guess if you want to, if you want to throw in, I guess I can throw in 2 there so we have something there. Now, what happens when we get over to the right side here? We're going to be doing things like +2, 2, +1, 1, things like that, realizing same slopes but opposite signs. Okay, so I'm not going to keep writing out. We're going to make our slope field. Ready? This is something that goes a lot quicker on your own because it just does. Like a lot of things I teach, you can do them quicker on your own. So, okay. I'm starting right up here. We'll get these. -2, 2, so that was -2. I gotta think so. Negative direction, a little steeper than 1. Yes? -2, 1, so -4, so that's going to be negative, but even steeper. A does not exist slope, we don't do anything. Okay? -2, -1 is going to be 4, but positive. So I'm going to go, that's going to be my steepest mark on here, right? So that's steep. And then we have 2, so positive but less steep. Okay, next. -1, 1, 2 is -1, so negative direction, but not as steep. That's that 45-degree angle. -1, 1, -2. So this one is going to be kind of our middle steepness, if you will. I'll put nothing at -1, 0. What do we have down here? -1, -1, 2. So positive. Middle steep. And then -1, -2 is going to be a slope of 1. Okay. Now, what about on the y-axis? I'm going to put something. What's the slope on the y-axis?
It's going to be 0.
When x is 0, the slope is 0. So a slope of 0 is a horizontal line. Now, I'm not going to put anything at 0, 0. But just because 0 over 0 is a weird case, right? So we're just not going to put anything there. Now, can you reverse over in the star quadrants? Easier said than done, I know. Okay, so what? 1, 2, is that going to be a positive 1? Then this is going to be a positive 2 here, right? Down here, we're going to have to go, what, -2, and then, see, I have to stop and think about this, -1. Then your 2 row, you're reversing them. So where did we start? Was -2, so now we're going positive 2. Positive 4 is steeper. Nothing there. Down here we have -4 now, so steepest, and -2. Okay. Now, this is a little bit more interesting one to kind of see what's going on here. If we solve this, which I do have it solved in my notes because I do want to talk about a little bit, and I'm actually going to relate it to a graph from pre-calc that you haven't talked about for probably over a year at this point. Okay, okay. Let's separate our x's and y's. What's going to happen here if we separate our x's and y's? Multiply the y over. I have y dy. Multiply the dx over 2x dx. And then if you integrate, integral of y is going to be add 1 to the power, divide by the new power. So 1/2 y squared. What's the integral of 2x?
No, x.
Add 1 to the power. If you divide by a new power, the 2 cancels, right? And then officially you need to say plus c. Okay. Okay, now if we try and solve this for y, we've got a couple of different options here. If we try and solve it for y, to get rid of a 1/2, multiply by 2. Now, no, I'm going to write this as y squared equals 2x squared, and then we haven't learned a lot about c's yet. I'm just going to leave it as a plus c, okay? Because we don't even know what that c is right now. It's just some constant. So a lot of times you'll just leave it as a plus c, okay? You won't necessarily write it as 2c or anything like that. Officially, if we solve this for y, what's one option? Y equals the square root of 2x squared plus c. What do you have to do when you take the square root on both sides? A plus or minus. Now, to be honest, I don't know if I'm going to comprehend what that looks like. Y equals the square root of an x squared graph. Like, I don't exactly, know if I'm going to figure that one out. The other way to write this, okay, let's take this right here. I'm going to subtract the 2x squared over, and I could write this as y squared, minus 2x squared equals c. Now, that is a graph we learned last year. In our conic sections chapter, and in our conic sections chapter, we had parabolas, which were y equals x squared or x equals y squared. We had ellipses. Ellipses were like ovals. And they were x squared plus y squareds. And then we had hyperbolas. Hyperbolas where we had the 2 going out, and they were x squared minus y squared or y squared minus x squared. Okay? So this is actually a hyperbola. Now, it's not anything I'm expecting you to try and draw in here. Since it's y minus x squared, it would be something where your hyperbolas, my hands don't turn the right ways, but my hyperbolas would be going up and down since the y variable comes first. Okay, so we'd have them going up and going down. Okay, because keep in mind, this guy right here, my slope doesn't exist on that x-axis. Okay, so, well, and that's, remember hyperbolas can be out on the x-axis, like going out horizontally, or vertically y-axis. So, I know, I wasn't expecting you guys to remember that, because we kind of do it that one time, and then it doesn't really come up a lot. Parabolas do, but the rest doesn't. So, till you get the right course, they don't come up a lot. Okay, guys. Got it? Okay. Now, we're going to spend a little time delving into, looking for patterns. Okay? We kind of started looking for patterns here, right? I didn't work out every single XY pair. Because we kind of, all my signs are going to flip, as you realize. And in that particular case, each quadrant had its own sign, didn't it? Positive or negative. Okay, so let's look at example 3 here. And with example 3, it says, consider the following equation, dy dx equals negative x over y. And I think if I recall, we're using the app. This whole page goes together. Now, compute dy dx at each set of points and then answer the following questions. So, here's dy dx, right? What about at the ordered pair, 1, 1? What's dy dx going to be? Negative 1, because it's going to be the negative of 1 over 1. What about at negative 1, negative 1? Positive 1, because it's going to be the negative of negative 1, so positive 1 over 1. What about at negative 1, negative 1? Negative 1. And what about at 1, negative 1? Positive 1, yes? Now, if you look at what the blanks we have to fill in, dy dx is positive in quadrants blank and negative in quadrants blank. Okay, well, let's go through. 1, 1 is what quadrant? Quadrant 1, yes? Right, 1 up 1. Where's negative 1, 1? It's going to be quadrant 2. Negative 1, negative 1? Quadrant 3. And 1, negative 1. Sorry, I need the labels there. That's going to be the easiest way for me to put it all together. So, dy dx is positive in which quadrants in this case? Okay, quadrants 2 and 4. I wrote with Roman numerals in my notes. And negative in quadrants 1 and 3. Okay. Now, folks, when we get down to Part D, we're going to be doing the slope field. Okay? So this is kind of helping us to be ready. Part B, compute dy dx at each set. So again, remember we're using dy dx is, which is it? Negative x over y.
D and E, the question are all D and E. Right? Yeah.
Because in every case, what's going on? A y value of 0, yes. And if you've got a y value of 0, now I actually used u and d for undefined. You know, different ways to say it. Okay. Write an equation that would describe the slope as undefined and then the slope as 0. So when is the slope undefined? What type of line? A vertical line. What's an equation of a vertical line? Vertical lines are x equals some number, yes? Could be x equals 3, x equals 2, x equals -5. Or the generic way of saying it is x equals a, where of course a is a constant. Now, I have written in my notes any vertical line. Okay? That's something you guys have been learning since Algebra 1, right? Vertical lines, undefined slopes. What about the slope of 0?
Y equals A.
Okay, y equals a. Yep. I was debating if I left as y equals a in my notes or used y equals b, but horizontal lines are y equals a number, and it's any horizontal line, isn't it? Okay. Now, that's kind of covered 2 with 1. When the y's are 0, you've got undefined. If the x's are 0s, you're going to have a horizontal line, you know, a slope of 0, right? Okay, next set. Consider these values. Again, we're using dy dx equals negative x over y, right? I think I would know this by now, but okay. 1, 1. 2, 2.
Negative
1,
one.
-1.
Negative 1.
-2, -2.
Negative 1.
Okay. What equation would express dy dx equals -1? So
When x equals y, like when they have the same number.
except when we were plugging these in here, there was a negative that played into it. So
Negative x over y.
this one is not, it's going to be, if we want a negative slope, because remember this is saying dy dx equals -1, so a negative slope. It's actually going to not be when y equals x, but y equals the opposite of x. So y equals -x is what we're looking at here. Does that make sense? And I know yeah. And again, it has to do with this negative sign up here that's making it thrown off there. What about when dy dx equals 1? That's going to be y equals x. Okay, in a... I feel like those are backwards, though. Now, which way were we asking this? I am second guessing.
Yeah, because y equals x in the first one, but still negative 1. Okay.
Let me double check something real quick. I think take my time. Here's my struggle with it. Are we referring to just in general, or are we referring to this specific situation? You would assume we're referring to this specific situation.
It would be y equals x.
And so, yeah, if we're referring to a specific situation, then we should be flip-flopped. And so I am second-guessing this. Where am I trying to go here? Yeah. Okay. And that's what I thought. I probably I'm going to guess the answer key is wrong on this one. Okay. Yeah, I am. I'm going to go back with Aiden's initial thought here because sorry. Now wait, which one is, so if we're using this scenario, and that's the only thing I think is this is, generally speaking, if the slope equals -1, you would expect x and y to be opposites. But in this scenario, because there's a negative in the equation, they actually need to be the same sign. And in order to get the positive slope one, you would need opposites. Yeah, I'm going to have to do some research into that, but I think that is a typo in the answer key. Okay. What do you think? Can we get this slope field done? Maybe, maybe not. We've kind of done lots of information along the way. We decided that slopes, in quadrants 2 and 3 are going to be positive. No, 2 and 4. I can't read oh my gosh. I can't hold it out far enough. 2 and 4 are positive, right? Yeah, and 1 and 3 are negative. I'll get this. We decided that, when y is 0, the slope is undefined. When x is 0, the slope is going to be 0. And then when the slopes are 1 and -1 is going to be when y equals x or negative x, right? Okay. And so I tend to go ahead, like if I start with the zeros, I like to start with zeros. You can start wherever you want, but when y was 0, that's going to be on the x-axis, my slope was undefined. So I'm not going to put anything there. What about when x is 0? When x is 0, my slope is going to be what? 0. So I'm going to go here where x is 0, and I'm going to put my 0 slopes in there. Now, okay guys, think about what's the line y equals x? The line y equals x is that perfect diagonal line, right? I'm taking that out, but just visual. What's true of those slopes? They're all going to be -1. So could we go ahead and put those in?
Yeah.
-1, -1, -1, -1, -1, -1. These are the kind of connections you can look for. And this is kind of what this problem talked us through. Now, what about on the line y equals -x? The line y equals -x is that guy, right? I'm getting ready to take off. When the line is y equals -x, the slope is +1. Whoops. Notice I just skipped over 0, 0. 0, 0 is a weird, like, it's nothing. Okay? Now, in terms of otherwise, you really just kind of need to go through, I mean, we know like in quadrant 1, for instance, we're going to have all negative slopes here. Okay? It's x over y. So like for instance here, that's going to be 2 over 1. 2 over 1 is going to be slope of 2. So I'm going to make it steeper. When I go right here, that's going to be 3 over 1. So it's going to be steeper. Is that making sense? If I go to, what is this? 1, 2. That's going to be 1 over 2. So that's going to be 1/2. So that's going to be less steep. If I go right here, 1/3, 1 over 3, less steep. Let's see, I need to go back and get 2, 3, x over y, 2/3. So a little bit less steep than 1, steeper than 1/3 and 1/2, you know. The other piece I'm missing here, 3 over 2, that's going to be 3/2, so make sure it's steeper than 1. Does your first quadrant look something like that? Okay, kind of, fair enough. The other quadrants are all going to be similar. I'm just going to personally have to go through and redo all those numbers because, you know, it's easier said than done. You'd think you could just copy these to the other quadrants, but I can't. Okay, so I'm ignoring the negatives because we know in each quadrant what's going on. And I'm just looking at numbers, x over y. So right here, -2, 1. 2 over 1 is what I need to worry about. So it's a slope of 2. If I go over right, 3 over 1. Okay? If I go straight up, 3 over 2. Let's see, if I go -2, 3, that's going to be 2/3. So a little less than 1. Then the 1 column, 1 over 2 is 1/2. So less than 1, and 1/3 is even less. Repeat in the bottom 2. So x over y, -2 over -1. So 2 over 1 is going to be 2. And I'm going with, we already have the signs, yes? So hopefully you're going with the same signs. 3 over 1 is going to be steeper. 3 over 2, less steep. 2/3, 2 over 3, less steep there. And we have 1/2 and 1/3. Are you seeing a picture happening?
Circle.
You got it. Okay, so what do I have here? 2 over 1, 3 over 1. That was 3/2. I'm starting to get these memorized. 2/3, and then 1/2 and 1/3. And the bell's going to ring. So we will talk about our circle tomorrow. Oh, and I guess there's some G and H there. As I said, I don't think I would finish the notes with e-learning. I think I would go a different route. So have your books with you just to be safe. Could be AP Classroom, could be something in the back of the book. I don't know.